the second topic today. But before I do that, I need to, just to get all grounds covered, I need to talk about side effects. We just need a list of things we can't do. And that constitutes basically what are side effects. Okay. Anyone? Have you heard of this term? Yeah. Okay. Just give me examples. What are side effects?
The function take a variable which mutate the variable.
Okay. Mutation. Mutation. Your example would be a function takes a variable. Let's say this one is a number. Well, you can't do a mutation on number. Okay. This one is an object. You do a dot p equals 1. You can't do this. That's mutation. Another example would be let a equals to 1. Later on we do a equals to 2. That's mutation. That means just use this instead. You can't do yeah, you just use const all the time. There's no let, basically. But const doesn't prevent you to do
objects.
Yeah, right? Okay. You can still do a dot a equals to 2. So that's mutation as well. We can do that. What else? What are side effects? IO. Okay. What's IO? Examples? Right. Okay. Console.x. Right. And what are IO? Other IOs we do.
Fetch.
Fetch. Yeah. Fetch. Read file. Write files. Yeah. Basically, in any like fetch code, network, all that stuff. Anything else? We'll get to that list later when we encounter one. So, because we're dealing with JavaScript, it doesn't have. Okay, I should say that in like pure functional programming, the runtime gives you the ability of I/O. So when the program has been compiled, it will do I/O regardlessly. Otherwise, it's not useful, right? We will embed that part in JavaScript. That's, we can't get away from that. We will do I/O and mutation we separate them in a way that some library produce it. We have a unique construct. We draw a line to say, here is my JavaScript parts are functional. It's equivalent to other function language exists, and this part actually does mutation, does side effects. This part is equivalent to the compilers in other functional language. Okay, we have very like a line to separate those two things in JavaScript. That's inevitable. We'll mention that as well. Okay, so let's move on to composition. We'll take this time. So get a bit of a compose here. To be honest, to understand this one, it's just the same with curry. Write it. So let's examine what's the requirement for a compose function. A compose function will take F1, F2, Fn. Itself is not carried for now. I will produce, let's say F1 is of type A to B, then, sorry, I need to write a reverse, do I? Okay, F1, F2, Fn. Okay. So F1 is A, this is type, arbitrary type from A to B. I should say like, I will use a bit of a Haskell notation here as well, because it's just easy to write because it's less characters. So it takes any type of A, produce any type of B. It may be the same type, A and B may be the same type, right? But it's A to B, just to illustrate this function takes a type of A, produces a type of B. And this function must take B to C. So, yeah. And here takes, how to write this? I don't even know how to write this type here. But refactor my type to A1 to B1, take B1 to A2. Does that make sense? So
A0 to A1, A1 to A2.
yeah, okay.
It should be Bn minus 1 to An.
Well, you get a gesture, right? Let's just write it like this. So here it will be like, you know, Y to Z, because this one produces Z here.
Yeah.
So